Let me ask you a question. Do you ever create reports in Microsoft Excel? And if so, do your reports happen to summarize data that's been exported from some external data source, such as an accounting system? If so, this course is for you. We'll examine a powerful technique known as mapping tables that helps to automate recurring use reporting workbooks, even when the report labels are different than the data labels. Wait, what? Let's say you export data from an accounting system and you have a data row named cash, but your report label is named cash and cash equivalents. Since the labels are different, you're prevented from using lookup functions or other Excel formulas to pull the values from the data sheet into the report sheet. In this course, we'll explore how we can use the tables feature and the SUMIFS function to provide Excel the information to translate labels as needed. We'll use my Journal of Accountancy article, The Power of Mapping Tables, as a guide for our discussion. Now, let's get started. Let's talk about one of the biggest pitfalls Excel users have faced for the last, 25 years. Let's say we have a range of data in our worksheet. Let's use range A2 through A9 as an example. Then we do something with the range. Maybe we use it in a pivot table or a chart, or maybe we have a formula that uses the range, such as a sum function to add up the values, shown here in cell C2. The sum function works, we save the workbook, close it, and life is good. Until next period. We open the workbook to update it, we add new data under the range, starting in cell A10. Now, let me ask you a question. Is this newly entered data included in the sum function? As you already know, the new data is not included in the sum function since it was entered outside of the function argument range A2 through A9. Unfortunately, the sum function doesn't automatically update itself to include data that the user entered under the range. In fact, anything in Excel that uses the original range does not automatically update itself to include the new data, including pivot tables, charts, or other formulas. And this is a huge problem for Excel users. It creates errors and inefficiencies. What do you mean, Jeff, errors and inefficiencies? Errors because the sum function doesn't include everything that it should, and that's an error. So we need to go update all worksheet formulas that reference that range, and that's inefficient. Starting with Excel 2007, Microsoft addressed this issue in a wonderful way with the introduction of tables. To use the table feature, you start with an ordinary range of data, and then you convert it to a table or table object. It's easy to do. Start by selecting any cell in the range, and then use the Insert Table ribbon command. Or, if you prefer keyboard shortcuts, use Ctrl-T. Once you've converted the ordinary range into a table, you get access to many special properties. First, the table name. Each table is named, and you can reference the data within the table by using the table's name, rather than traditional A1 style range references. Next is auto expansion, and oh yes, it's as cool as it sounds. Tables automatically expand as new data is entered. That's right. If you type or paste new data immediately under or to the right of a table, it will automatically expand to include the new data. Any formulas that use the table's name will automatically include the data, since the table includes the new data. And the crowd goes wild. I know, right? Structured table references enable you to refer to selected regions within the table. The table's name refers to the whole table. Structured table references refer just to selected columns or rows, which comes in handy when writing formulas. Have you ever worked in a workbook that has a range of data and then over to the right you have a calculated column or series of calculated columns? You know how you have to sort of babysit those columns each month and fill them down manually if new data is added? Well, we can delegate that babysitting task to Excel. Tables automatically fill down calculated fields as new data is added. Tables also provide automatic totals, which you can toggle on or off anytime. Column label replacement. You know how when you scroll down a sheet that contains a large data range, you sort of lose track of which field is in which column? Typically, you might freeze the worksheet header in order to keep track of that. Well, when working with data stored in an active table, the standard column labels, A, B, and C, are replaced with the table's column headers as you scroll down, which is pretty nice.
This video is a production of Excel University.
I'll open the Tables workbook. let's convert this ordinary range into a table. Select any cell on the range and then Insert Table. Confirm the table has headers and click OK. You'll notice Excel converted our range into a table. When the table is active, we get access to the Table Tools ribbon tab. This ribbon tab provides many tools for working with tables, including the table name field on the far left. The default table name is Table 1, but I recommend changing the name to something more descriptive. We'll name it TBL_data since table names can't contain spaces. Easy enough. Next, let's use a table in a formula and watch it auto-expand. In this exercise, we'll explore auto-expansion. Let's start by converting our range into a table. We like to use descriptive table names, so let's name it TBL_sales. Now, let's use a sum function to add up the table values. Our formula will use the table's name. Sum, open paren, and then there are several ways to get the table's name into the formula. My favorite way is to use the autocomplete list. Type the first few letters of the table's name, TBL, and then hit Tab to autocomplete. Close paren, hit Enter, and good. Let's inspect the formula and ensure it includes all values in the table. Perfect. And now for the moment of truth. Let's add some new data. Type the value, hit Enter, and bam! The table auto-expands to include the new value, and as a result, the sum function automatically includes the new value as well, and the crowd goes wild. In this exercise, we'll explore structured table references. Let's use the shortcut Control-T to convert our trial balance data range into a table. Let's name it TBL_TB. Now, we need to write a formula to compute total debits. We use the sum function and the structured table reference for the debit column. Structured table references typically begin with the table's name, in this case TBL_TB. Now, to reveal a list of structured references, use the open square bracket on your keyboard. The top of this list shows the column references and the bottom shows various row references. We need the debit column, so we select Debit and Tab to autocomplete. Close the square bracket and the function, got it. And we can do the same thing to compute total credits. Sum function, table name, column name, close it out, and got it. We use structured table references to refer to areas within the table. In this exercise, we'll explore the automatic fill down feature of tables. Start by converting our range into a table. Confirm the table has headers and OK. Now, we'll name this table TBL_tax data. Next, let's name the cell that stores our tax rate assumption. Use the name box and enter T_rate. Let's write a formula to compute sales tax in the first table row. The formula is the amount, which is the value in the cell to the left, times our tax rate, the named reference T_rate. Hitting Enter will enter the formula, and due to the fill down feature of tables, Excel will automatically fill the formula all the way down. Bam! To finish out the workbook, let's write the total tax formula. We use the sum function and the structured table reference for the sales tax column. Got it. As we add new data to the table, Excel will babysit the calculated field and automatically fill the formula down through all new rows. Now that's what I'm talking about. In this exercise, we'll explore the total row. Let's start by converting this range into a table. We'll name it TBL_vendor_purchases. You'll notice the Table Tools Design ribbon tab has a bunch of fun stuff to check out. One of my favorite items is the Total Row checkbox. It allows us to turn a total row on or off at any time. In this exercise, we'll explore the column headers. Let's convert the range to a table, and let's name the table TBL_transactions. When the table is active, that is, when a cell within the table is selected, as we scroll down the worksheet, Excel replaces the standard worksheet column labels A, B, C with the table's header labels. This makes it easy to stay organized when working with large data sets. There are many additional options available in the Table Tools ribbon. Let's convert this range into a table named TBL_checks. As you can see, Excel provides many table options, including various table styles. We can change the table style to one of many built-in designs. We can add a total row and emphasize the last column, the first column, and select banded columns. Take your time and have fun exploring the various table tool options. Chapter Recap. I think you'll agree that Microsoft hit a home run when they developed the Tables feature. Tables are a great way to store data, and I use them all the time. This storage container is flexible and allows us to use all of the special properties discussed. Data stored in tables can be used pretty much anywhere in formulas, functions, pivot tables, and charts. Since they auto-expand as new data is added, they are great for recurring processes.
This video is a production of Excel University.
SUMIFS function was first introduced in Excel 2007, and Microsoft puts it in the Math and Trig function category. It's officially known as a conditional summing function, but that description is too sterile and lacks passion. I prefer to put this function in the awesome category. A conditional summing function is like a sum function because it adds numbers, but it includes only certain cells or rows within the sum range. I like to think about conditional summing like this. Add up this column of numbers, but only include those rows where this column is equal to this value. So in the screenshot, it would be add up the amount column, only include those rows where the cust ID column is equal to our cust ID. This is the exact same logic that the SUMIFS function uses. The first argument is the column of numbers to add, the sum range. Next, the arguments come in pairs, the criteria range and the criteria value. Up to 127 pairs are supported. So add up this column, only include those rows where this is equal to this. Think you got it? Let's flip to Excel and open the Conditional Summing Basics workbook. Exercise 1. Here, we need to create a report based on the data. We'll use the SUMIFS function to compute the subtotals for each account. So, equals SUMIFS, add up the amount column. Since we're going to fill the formula down, we lock down the reference with the F4 key. Only include those rows where the account column, since we'll fill the formula, we lock down the reference, is equal to our account. Close the function, and before we hit enter, let's review. We want to add up the amount column and only include those rows where the account column is equal to our account. Hit enter. Good. Fill the formula down to complete the report. And the crowd goes wild. I know, right? Let's have even more fun and use the SUMIFS function with a table. Exercise 2. Here, we want to create a report based on the data. The data is stored in a table named TBL_export. Our report needs to reflect the subtotals by account and by name. SUMIFS can easily handle this task. Equals SUMIFS, add up the table's amount column, only include those rows where the account column is equal to our account, and where the name column is equal to our name. Close the function, and before we hit enter, let's review. Add up the amount column. The remaining criteria arguments come in pairs. Only include those rows where the account column is equal to our account and where the name column is equal to our name. Hit enter, and got it. Fill the formula down to complete the report. Now, let me ask you a question. Could we use the SUMIFS with 3 different conditions? You can, and you will when you work through the remaining homework exercises. And that, my friend, is the basic idea behind conditional summing. Just remember the phrase, add up this column of numbers, but only include those rows where this column is equal to this value.
This video is a production of
In practice, there are times when the label on one sheet is different from the label on another sheet. For example, the label on the trial balance sheet may be cash, while the label on the balance sheet may be cash and cash equivalents. In these kinds of situations, it is fairly common practice to retrieve the balance sheet value from the trial balance using a direct cell reference, such as B15. This type of direct cell reference is a huge problem for recurring use workbooks. For example, the value's location may change in a subsequent period, or the user may sort the data. Thus, we prefer lookup functions to direct cell references. When the two labels are the same, for example, cash and cash, there's no problem and everything works as expected. However, when the lookup label, for example, cash and cash equivalents, differs from the label stored in the lookup range, for example, cash, the function breaks. This chapter introduces the idea of maps, or mapping tables, which enable us to use lookup functions and conditional summing even when labels differ. We'll also discover that maps enable us to distribute a value in a source table to multiple reports stored in multiple sheets, even when the report uses a different label or term for the value. Indeed, the map becomes an important sheet for many recurring use workbooks. The map is simply a reference table that maps one label to another. Since we lay out the map in a table, it's easy to use Excel formulas to translate between the two different labels. This structure also makes it easy to aggregate many rows into a single report row. For example, mapping 3 trial balance accounts to a single balance sheet row. The mechanics are easy. We basically rely on our dear friend SUMIFs to pull the numbers from the data source to the map, and then from the map to the report. With the mapping workbook. Exercise 2. Here, we need to get a trial balance to flow into a balance sheet. The balance sheet is here on the Exercise 2 worksheet. The trial balance is stored on the data sheet. The data is stored in a table named TBL-E2 data. Since the labels are different, we'll need to set up a map. The map is here on the E2 map sheet in a table named TBL-E2 map. This map stores the translation between the trial balance and the balance sheet. Step number 1 is to get the data from the trial balance into the map. Equals SUMIFs. Add up the trial balance table's amount column. Only include those rows where the table's account name column is equal to our account name. Close the function and enter. Good. Now step 2, getting the data from the map into the report. On the balance sheet, we'll use a SUMIFs function. Equals SUMIFs. Add up the map table's amount column. Only include those rows where the FS line column is equal to our label. Close the function and enter. Good. Now we just copy the formula and paste, paste, and paste. Good. This is beautiful. The labels are different and we actually mapped many accounts to a single financial statement line. Plus, we can paste in an updated trial balance anytime. The map will immediately pull the updated values and the report will immediately pull in the updated map values. That's hands-free reporting, baby. Now, let me ask you a question. Is it possible, using this technique, to route an account value to many different reports, even if the labels on each report are different? I'll let you think about it a moment before you do just that in the homework exercises. The simple idea of mapping is powerful. It allows us to automate the data flow even when the labels are different. Exercise 1. In this exercise, we'll get warmed up with a simple mapping table. Let's take a quick tour of the worksheets. The E1 data sheet contains the data. The data is stored in a table named TBL_E1_data. This data needs to flow into the map. The map is stored on the E1 map worksheet. The table is named TBL_E1_map. The map data needs to flow into the report. The report is stored on the Exercise 1 worksheet. Step 1 is to pull the data into the map. On the map sheet, we'll use a SUMIFS function. Equals SUMIFS, add up the TBLE1 data amount column, only include those rows where the TBLE1 data rep ID column is equal to our rep ID. Close the function and hit enter. Now that the data has been pulled into the map, let's build the report. Here, we'll use the SUMIFS function to retrieve values from the map. Equals SUMIFS, add up the TBLE1 map amount column, only include those rows where the TBLE1 map rep name column is equal to our rep name. Fill the formula down, and we got it. Exercise 2. In this exercise, we'll use conditional summing to map many data items to one report item. This setup is similar to the previous exercise. We have a data table on the E2 data sheet. The table is named TBL E2 data. This data should flow into the map. The E2 map sheet has the mapping table. It's named TBL E2 map. The report on the Exercise 2 worksheet should pull the values from the map. Step 1 is to pull the values from the data table into the map. Equals SUMIFS, add up the TBL E2 data amount column, only include those rows where the TBL E2 data account name column is equal to our account name. So far, so good. Now, let's build the report. Equals SUMIFS, add up the TBL E2 map amount column, only include those rows where the TBL E2 map FS line column is equal to ours. We simply copy and paste the formula down throughout the report. Copy, paste, paste, and paste. Perfect. Exercise 3. In this exercise, we'll use a single data table and a map to feed multiple reports, even though they use different labels. The data is stored on the E3 datasheet. The table is named TBL E3 data. This data will be pulled into the map. This mapping table includes two report label columns. The B sheet column is for the balance sheet, and the PL column is for the P&L. We pulled the data into the map. Equals SUMIFS, add up the TBL E3 data amount column, only include those rows where the TBL E3 data account name column is equal to our account name. Now, let's jump over to the report. We'll start by building the formula for the assets. Equals SUMIFS, add up the TBL E3 map amount column, only include those rows where the TBL E3 map B sheet column is equal to our label. Fill this formula down. Now, let's copy this formula and paste it into the first liability row. As we can see, the underlying data represents credits with negative numbers, so we just need to flip the sign here. Precede the SUMIFS function with a dash, and that should work just fine. Copy this formula and fill it down through the remaining rows to complete the report. Now, let's work on the P&L. Equals SUMIFS, add up the TBL E3 map amount column, only include those rows where the TBL E3 map PL column is equal to our label. Precede the SUMIFS function with a dash. Equals SUMIFS, add up the TBL E3 map amount column, only include those rows where the TBL E3 map PL column is equal to our label. Now, just copy and paste the formula down to complete the report. Extra Credit 1. In this exercise, we'll write a consistent formula that can be used throughout the report. The key here is the nature column. This value will tell our formula if the sign needs to be flipped. There are several approaches to writing the formula. One way is to pull the value with the SUMIFS function and then use an if function to determine if the sign needs to be flipped. If the nature is dr, then we multiply the result by 1. Otherwise, we multiply it by -1 to flip the sign. Let's build the formula in 2 steps. First, let's just get the SUMIFS working correctly. Equals SUMIFS, add up the TBL-E3 map amount column, only include those rows where the TBL-E3 map B sheet column is equal to our label. Close the function and hit enter. Okay, that's looking good. Now, let's flip the sign if needed. Edit the formula. If the sign needs to be flipped, we'll multiply the result by -1. If the sign does not need to be flipped, we'll multiply the result by 1. So, SUMIFS, okay, times, if the nature is equal to dr, then 1, otherwise -1. We copy and paste the formula down. Copy, paste, paste, and paste. Excellent. The P&L is done the same way. Equals SUMIFS, add up the TBL-E3 map amount column, only include those rows where the TBL-E3 map PL column is equal to our label. Multiply the result by if the nature is equal to dr 1, otherwise -1. Copy, paste, and paste. Nailed it.
This video is a production of Excel University.